All right, 7, 8, and 9, we are doing a word problem on combined variation. We have direct variation or joint variation, it's the same thing, and we have inverse variation. So when we did direct variation, we set it up as a fraction. If it varied directly, we'd had x over something. If it varied inversely, we set it up as a multiplication. Now again, I do these different than on the LX program because the LX program has you find the constant of variation first. But if you're not looking for the constant, it's quicker just to set up your problem without finding that constant first. So if I'm going to set up my formula, it says the force needed to keep a car skidding or from skidding on a curve varies inversely as the radius of the curve. So the force varies inversely as the radius. I would multiply the force times the radius. And jointly as the weight of the car and the square of the car's speed. So jointly is the same thing as directly, the weight of the car and the square of the car's speed. So for each part, I want to set up one fraction equal to the other fraction with the information that I know. So it says suppose that 200 pounds of force keeps a 3,200 pound car, that's my weight, from skidding on a curve with a radius of 400 feet at 25 miles an hour. There's my speed. My speed was squared. Then I'm going to do the other part. What force, so I'm trying to find F, would keep the same car from skidding on a curve of a radius of 550 feet, same weight, at 55 miles an hour. So I need to solve that for F. So if I'm going to solve that for F, I'm going to multiply by those two things. I'm going to divide by that. So I'm going to have 200 times 400 times 3,200 times 55 squared over my 3,200 times my 25 squared times my 550, right? So I'm going to multiply by those, divide by that, it's going to end up on the bottom. Now just to shorten up my calculator, where since I have that both on the top and the bottom, I can go ahead and cancel. And then since I'm going to use a calculator, I'll just leave the rest like it is. Find my calculator here. So I am going to take 200 times 400 times 55 squared, and then I'm going to divide that by, and I'm going to use parentheses since I have more than one thing on the bottom. So divide that by parentheses, 25 squared times 550. Close my parenthesis, and I get 704. So 704 pounds of force. So here it took 200 pounds of force. Here it's going to take 704 pounds of force. Part of it, I'm driving faster, so I need more force. So when you do that, what I did here is I figured out the top number, I divided it, and then put parentheses around the bottom. You could figure out the top number, figure out the bottom number, and then go ahead and divide your answers. That would also work. So number 8 here, if I'm going to set this one up, it says the drag of force F on a boat varies jointly with the wet surface area. So this time I'm going to have F over the area, jointly as the area of the boat and the square of the speed. So S squared. We don't have any inverse variation, just joint variation on this one. So it says a boat with a wet surface area of 50 feet squared is traveling at 7 miles an hour. So we got to do 7 squared. Experience a drag force of 98 N. So I'm going to have 98 over 50 times 7 squared. We want to find the wet surface area, A, if it's traveling at 7.5 miles an hour and has a drag force of 135. So now when we solve this one, since my A is on the bottom, I have to think about cross multiplying. I would have A times 7.5 squared times 98 equals 135 times 50 times my 7 squared. And so in order to solve this for A, I'm going to divide by the 7.5 squared times the 98. So again on my calculator, I'm going to do the top first. So 135 times 50 times 7 squared. I'm going to hit equals, get my answer. If you wanted to, you could write it down. Then I'm going to divide it by and put parentheses around the bottom. So on the bottom I have 7.5 squared times 98. Close my parentheses, hit equals, and I get 60 for my wet surface area. So number 9, this one says the volume of a fixed amount of gas varies directly. So I'm going to have it over the temperature, varies directly as the temperature, and inversely as the pressure. So it's going to be times the pressure. Directly as the temperature, so I divide by the temperature, inversely as the pressure, so I'm going to multiply by the pressure. So suppose that V is 42, when T is 84, and P is 8. Find the pressure when my volume is 74 and my temperature is 185. So since this one has the P on top, I can just multiply the 74 down here and the 185 up there to solve that for P. So again, I'm going to take the 42 times the 8 times the 185. I'm going to divide that and put in parentheses the 84 times the 74. Close my parenthesis. I get 10. So direct variation, you divide by that variable, direct or joint. Joint just means there's more than one. And inversely, we're going to multiply by that variable. And then we fill our values in and solve it as we need to solve.